So what we have now is we have a way to represent our item as a vector. We looked at movies, but again, the same thing works in the same way for anything else, books, videos, music, and so on. We length normalized the vector, and then we computed the similarity using the cosine measure. And as you've seen on the example, this is one way to make item recommendations. In the example on the worksheet, we are using tags, which is one of the most common ways websites interact with users in labeling items, the so-called collaborative tagging. Now you have this pretty much everywhere on all kinds of websites, e-commerce websites, music videos. The users can tag them, and then we can use these tags to build vectors that we use for recommendations. So the first step was this simple tag-based recommendation. We are looking at the tags, we're building the vectors, and then we find the most similar other item related to an item. So related to a video, we can find the ones that were tagged very similar. And again, this is used on all kinds of websites, music, images, videos, and so on. By the way, does anyone know the groups that are shown here? Anyone listening to Tom Waits, Led Zeppelin, Pink Floyd, Jethro Tull, or have you never heard of them? Now we want to go one step further. We want to do more recommendations. We want to personalize them. So the first thing we have already done, we have recommended items related to other items, but now we also want to be able to recommend items based on the interest of a user, and also do it the other way around. When we have a new item coming in, a new video being uploaded, we want to find out which users would be interested in it. And you can see that we can use the exact same representation, this vector space model, with the idea of the similarity to implement all of these different recommendation techniques. So the first part we have already done. This is a simple point-to-point recommendation engine. So we created the item vectors using the raw count. And in our case, we use the raw count of tags, but you can also use any other kind of interaction that users liked something and whatever you have collected as metadata. We then normalized the vectors, computed the cosine similarity, and created the similarity matrix. Now we want to find out what are the items of interest specific to a user. The one that we've done so far, this item-to-item matrix, is the same for all users. We don't distinguish when we say movie 2 is similar to movie 1. We don't distinguish based on the interest of a user. But as you've seen earlier in this Netflix video, this doesn't really work. We want to be able to highly personalize to make it specific to the interest for one specific user. So what we have to do now is to build a user-specific similarity matrix. And the way we do it is, in the beginning, it's the same as before. Now we're computing these vectors, we normalize them. But now what we calculate is the similarity between a user vector and an article vector. So on the worksheet, there are 2 more tasks. So what we need to be able to make personalized recommendation is the information about the user. So that's, again, what I showed you earlier, the interaction a user had with the system, what a user liked, what a user bought, what a user watched. In this case, we can, for example, say how many times a user watched a movie in that category. So what we have now is for each user, we have this vector, now same number of dimensions. And the first step you have to do is the same as before. You compute the length and you create denormalized vectors, just like you did before for the movies. And then we build another similarity matrix using the cosine similarity, same calculation as before, but now we calculate the similarity between a user and a movie. And this is what you need to find out. What is the user interested in? Which is the best movie to recommend to this specific user? And you can also use it the other way around. Yeah, you can, you have a new movie coming in, and then you can say, which user are the ones that I want to recommend it to? So have fun with the calculations, and don't forget to post the results on the Moodle forum, and I'll see you in the next lecture part.